Okay guys, so this is going to be the video for solutions for the functions. So this video should be accompanying the PDF I sent you guys earlier this week. I gave you 10 or so questions about functions. So the first one, if you just want to follow along, it's going to be 18, and it's going to be y equals x plus 1 over x minus 1. And it's asking you which of the points in the xy plane is not on the graph. So you're looking for, so you're given a set of points here, a, -2, 1/3, b, -1, 0, c is 0, -1, and d, which is 1, 2. So it's asking which of the following points is not on the graph. So 3 of these points are actually going to be on this graph here. One of them is not, and that's the one we have to solve. So the easiest way to do this is we could just plug in numbers and see. So let's plug in. Let's look at c. This looks easy. So we're going to plug in 0 for x, right? So you'll get 0 plus 1 over 0 minus 1. Well, that's sorry about that. It's simply 1 over -1, or -1, right? So our y value is there. So c is on the graph. Let's look at b, right? So we plug in -1. We'll get, for x, we'll get -1 plus 1, -1 minus 1. This is just 0 over -2, which is just 0 for our y value. So b is on the graph. And we can look at d. D looks simple to plug in, right? You have 1 plus 1 over 1 minus 1. Oh, so this is going to be problematic. So you'll get 2 over 0. So this actually can't be on the graph. This makes a function undefined. So d is going to be the right answer here. Because not only does it not lie on a graph, it's not even a valid point because it makes the function undefined. So just to show you, -2, 1/3 should be on there. So we'll do -2 plus 1 minus 2 minus 1. This gives us -2. This is -1. This is -3, or 1/3. So that is actually on the graph too. So that's how we do 18, and that's simple enough. Let's look at 19. So we have g. So we should just be following along. This is question 19. G of x equals square root of 3x, right? If g of a equals 6, find a. Find a. Okay, so with this one, we're just going to see we have g of x equals square root of 3 of x. So we're looking for a, so let's plug in a. So we'll say g of a, we know, is square root of 3a, right? But this also equals g of a also equals 6. So that means square root of 3 of a equals 6, right? Because if g of a equals square root of 3 of a and g of a also equals 6, then these must equal each other. So then we could just simply solve for a here. So we'll square both sides. We'll get 3a 6 squared, right? Or that's just 36. So 3a equals 36. We'll divide by 3. 3. You'll get a equals 36 divided by 3 is 12. So a should be 12. And that is answer choice D, right? Okay, so let's look at 20. 20 and 21. They follow a chart. I'll do the chart really quick here. So we have x, f of x, g of x, right? And we'll get -2, 3, 4, -1, 5, 2, 0, -2, -3, 1, 3, 5, 2, 6, 7, and 3, 7, 1. Okay, so we have x, and then we have two functions defined by x, f of x and g of x, and we get these values here. So it's asking us find f of g of -1. Okay, so this is going to be the first question it's asking us. This is question 20. So find this, right? So first thing we want to do is work on the inside, right? What's g of negative 1? Well, we know g of negative 1. We'll go look at our table. Negative 1, if I plug a negative 1 to g, I'll get 2. So g of negative 1 is just 2. So really I'm looking for f of 2, right? Because this is the same thing as f of g of negative 1, right? And I'll show you, right? Because 2 is the same thing as g of negative 1, so I can just plug that in. F of 2, let's see, f of 2 is going to be, where's 2? 2, so now plug in f of 2 is 6. So f of 2 equals 6. So question 20 should be D. 20 is D. That should be your right answer. And again, we're just using the chart here, right? So we work, when you're dealing with composition of functions, you want to work inside out. So inside says negative 1, g of negative 1. G of negative 1 we know is 2, because we can go negative 1. G of negative 1 is 2. And we can say 2, f of 2. 2, f of 2 is 6. So we'll look for answer choices, and sure enough, we see 6 for D. So that's how we got that. So now we're going to do, for this chart, we'll also do 21 with the info given. So let's do that right now. Let's see if I can get a better color. That color is not too nice. Dark green. How does this look? Oh, that's cool. Okay, so let's look at 21. 21 says if g of c equals 5, find f of c. Okay, so if g of c equals 5, find f of c. So what we're really looking for is what value for c, right? What number for c gives 5 when you plug it into g, right? So let's see. So let's look over here. So we have 4, 2, negative 3, 5. Here's 5, right? So what number do I need to plug into g to get 5? Well, I can plug in 1. So g of 1 equals 5. Okay, so if g of 1 equals 5, what we're looking for is, we know that we found c, right? So then c must be 1, right? Because g of 1 equals 5 equals g of c. So 1 and c are the same. So now I need to find f of c, or f of 1. Well, 1 is just going to be f of 1, right? I look under my f chart, f of 1 is just going to be 3. And that is answer B. So hopefully you guys got that. We can abandon that long chart now and go back to another problem. Okay, so let's look at 22. 22 is f of x equals negative 3x plus 5, and we're given 1/2 of f of a equals 10. Find a. Find a. Okay, so let's look at what we're given here first. What I'm underlining. So we have 1/2 of f of a equals 10. So 1/2 of this value, this function value, f of a, will give us 10. So let's try to isolate f of a by itself. So what we can do is we can multiply both sides by 2 here, right? So these cancel out. So you'll get f of a equals 10 times 2, or 20, right? So now we're looking for a. This is much more simpler when we're given this function here, 2. So when I plug in a to this function, I'll get 20, whatever that, and we're looking for that value a. So what I can do is I can do negative 3x plus 5 equals 20, right? Because this is just, or actually, you know what you can do is you could just say f of a, right? What you can do is say, well, I know f of a, if I plug in f of a, that'll give me 20, right? So I could just solve for it directly from here. So negative 3a plus 5 equals 20. Negative 3a equals 15, right? Take away but 5 from this side and this side. Divided by negative 3, divide by negative 3. So these cancel out. We'll get a equals negative 5. And that is choice B. Okay, so let's look at 23. So 23 is a chart, and there's only one question, so I'm hoping you guys have that PDF. I'm going to attach it when I send you guys this link anyway. But anyway, you have this chart of x values and f of x values here. So it says several values of the function f are given in the table above. If the function g is defined by g of x equals f of 2x minus 1, find g of 3, right? That's what it's telling us to do. Okay, so we're going to find g of 3. So what's our x value given to us? Well, it's just 3, right? X equals 3. So if x equals 3, I'm just getting a thicker marker here. X equals 3, right? Then g of 3 equals f of 2 times 3 minus 1, or that equals f of 6 minus 1 equals f of 5. So if I go to my chart, I can say, well, what does f of 5 equal, right? Well, f of 5 is just going to be 7, or choice D. So D would be the right answer. So just looking at that chart, we want to find what f of 5 equals, and it says f of 5 is 7. So, I'm sorry, ignore that. I rushed it. So, but this is all right up to this point here. This is all right up to this point. So g of 3, right, equals f of 5, right? So what does f of 5 equal? Well, if I plug in 5, right, so what's our x value we need to plug in? We need to plug x equals 5, right? So f of 5 then is going to be 2, or A. That was a tricky question. Okay, I messed up because what I was looking at, looking at f of x equals 5. To get f of x equals 5, you would need to plug in x equals 7, would give you 5, right? But plugging in x equals 5 gives you 2. So that's the crucial difference there. Okay. So if you're not paying close enough attention, you can get caught up like me. Let's look at 24. 24 says f of x equals 4x minus 3. G of x equals 3x plus 5. Right? Find which g value equals which g value equals, is it f of 8? So first thing probably is to find what f of 8 is. So f of 8 equals 8 times 4 minus 3. This is what? 32 minus 3, or 29. So now what we're going to say is, we're going to say 29, we're going to set that equal to our g function, 3x plus 5, because we want to find what x value will give us 29 when we plug in a g. So we'll just solve it. We'll say take away 5 from both sides, divide by 3, 8 equals x, right? So when I plug in x here, I'll get 29, and I'll also get, which is f of 8. So that answer is going to be D. Okay, let's do a different color. And let me see, do I have dark green? I like dark green, but can I add another pen? Oh, I can. Let's see. We don't have any purple, do we? Let's see what would look good. It's not. Can you do more color? No. Maybe that. There we go. Okay, let's look at 25. Okay, so 25 has this graph here. You have an upside down parabola. I'm going to try to draw it to scale here, but it would be best to look at it in your book for sure. So 1 here, 1, 2, 3 here. It's going to cross this x-axis here at 1, and then in between 2 and 3. So something like that, right? So this is our y equals f of x, right? Y equals f of x. Okay, so it's asking us, we're given another function g of x equals x plus 3, x minus 1, right? Which of the following which x will make f of x greater than g of x, right? Okay, so let's just start from the bottom. So we have, we can look here, we know this is 1, this is going to be 2 here, right? Okay, so let's start from the bottom where it says, just to try some choices. So 2 is d, right? So if I plug in, so 2 is d, if I plug in 2, g of 2, that's going to be 5 times 1, and that's 5, right? So that's greater than 0. I'm sorry, that's greater, I mean, yeah, obviously, right? 5 is greater than 0. But look at f of x. When f of x is at x equals 2, it's way negative. It's some this value here, right? This value here. This is negative, so 2 can't be right. So d's knocked out. Let's look at, so 2 can't be right. Let's try 1, right? So c, d is 2, c is 1, b, a is negative 3, negative 2. So d can't be right. Let's look at c equals 1. So when I plug in 1 to g of 1, I can already see I'm getting 4 times 0, that's 0, right? But if you notice, f of x at 1 is 0 too. So f of x can't be greater, they're equal. So f of x actually in fact equals g of x when x equals 1. So 1 can't be right. So now we're left with two negative numbers. We're left with negative 2 and negative 3. So again, we're just going to plug in it and try it out. We can get so we'll see g of negative 2 would be negative 2 plus 3 times negative 2 minus 1. That's going to be 1 times negative 2. This would be negative 3. So this is a negative 3. So g of negative 2 is negative 3. So it's a negative number. But if you look at your graph here, at negative 2, which is this here, f of x is positive. So that tells us that it should be b. And just to double check, we'll do a. Usually on the SAT, that's good enough. You guys want to also conserve time. And this should be good enough. And a is easy to check though. Plug in negative 3 here, you'll get negative 3. You'll get negative 3 plus 3, right, for your first one, and then negative 3 minus 1. We don't care about this. We know this is 0. So g of x is going to be 0 on that too. So since it's 0, of course, yeah. And then when you negative 3 on f of x is below the x-axis here, so it's negative, so 0 is going to be bigger than a negative number, so you're good. So that was just a way of double checking our work. But for the SAT, if you find one that works like B, just go with that. Okay, so let's look at 26. So 26 says if you are in the xy plane, the graph of the function g is the image of the graph of the function f after translating 1.5 units to the right, right? So which of the following defines g of x? So let's just do a quick refresher in case we don't remember translating functions. So let's say we have a function here. Like this, right? We'll call this f of x. And if you want to move it horizontally, what you need to do, like let's say we want to move it here. So now its vertex is here, right here. So it's going to look something like this, right? What you would need to do, you need to do f of x and you do minus, you go in this place 2 places, right? Because you're going 1, 2. And this will give you the new graph, it's dotted. That's how it's going to shift. And if you want to shift it to the left 2 places, so it's like this, right? Or actually, I'll just do a different color. We'll do this purple here. It's going to look like this. What you're going to get is f of x plus 2, right? And this makes sense, right? Because if this original graph is f of x here, when I add in a negative 2, I'm still going to get to 0, and that's 0, right? And if I add in a positive 2 here, it's going to give me 0. So if you're moving horizontally, if you're moving to the right, remember, you put a negative, you move to the left, you just put a positive. So our question tells us we are moving to the right, right? We're translating it 1.5 units to the right. So another tricky part of this question is what is 1.5? What does that mean, right? Well, we know what that means, but how can we work with this? This is called a mixed number, right? So to convert these, you need to multiply the bottom number, the bottom of the fraction, find the number here and then add it and keep the same. So let's do an example. We'll do this, right? 2 times 1 is 2. You add this one plus 1 and you keep the bottom 2, which is 3 halves, right? So okay, so 1 1/2 equals 3 halves, right? Okay, so this is now a number we can work with. Okay, so we're saying it moves 1 1/2 units to the right, and if you look at C, right? C is g of x equals f of x, or sorry, f of 2x minus 3, right? So if I plug in 3 1/2 here, if I say, okay, f of 2 times 3 over 2 minus 3, what does that give me? Well, that gives me f of 3 minus 3, right? Or g of 3 over 2, which equals 0. Right? That's perfect because that's saying we moved over 3 places, 1 1/2 places, or 3 over 2, and we end up getting the same value. So the answer should be C. Okay, let's look at 27. So we have f of x is a linear function such that f of 2 is less than or equal to f of 3, and f of 4 is greater than or equal to f of 5, and f of 6 equals 10. Right? Which of the following must be true? Okay, so this is a question that's really asking you to understand what does it mean when we say a function is a linear function. Well, we know that it's going to follow y equals mx plus b, right? And there's a few ways we can have linear functions. We can have them with positive slope, or you can have them with negative slope. And remember, there's two tricky ones. You can have one that's horizontal, or you can have one that's vertical, right? So these are the 4 ways you can have a linear function. Every linear function you can ever think of must look like one of these 4. Positive slope, negative slope, horizontal, no slope, and x, which is undefined. So this also has no slope, right? There's no rise over run. Or does it have, this has an undefined slope, this one, and then this one has a 0 slope, right? Because there's no rise and you could run forever, but this one actually would be dividing by 0. So if we look at this here, right, so what we're given is f of 2 is less than or equal to f of 3. So if I have my value here, f of 2, right, let's say this is 2, this is 3. So this number is less than or equal to this number here, right? So it can either be here or it can be here, right? Something like that. It can be at least, it can be the same value or bigger. But let's look at f of 4. f of 4 is greater than or equal to 5, right? So f of 4, and since we know this is a linear function, that must mean that f of 4 is either less than if it has a negative slope. Well, it can't be less than, right? 4 can't be less than because 3 is bounded, so it can only be here or here, right? Because it can't be lower than the red dot. And then 5, right, it can only be here. It can't be bigger than 4. So this tells us that for this function, and f of 6 is 10. f of 6, let's say this is 10 here. This is 10, right? So this tells us it must have it can't have a negative slope, it can have a positive or no slope, but it can't have a positive slope because 4 is greater than or equal to 5, so it must be a horizontal. So this is a tricky question. So if it's horizontal, that means every x is equal to 10, or in case D, f of 0 equals 10. So let's look at 28. 28 says the graph of the function g shown is defined by f of x. So this graph isn't shown, but this is a good graph to commit to memory. X cubed. This is f of x equals x cubed. If g is defined by f of x plus a, so g equals f of x plus a plus b. Find a plus b. Okay, so it's essentially asking you how was this graph shifted, and then add those two numbers up. So let's see, we have a, so the new graph is going to be 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 1, 2. It's going to look something like this, right? I'll do it in red. So it's going to look something like this, right? So it moved over how many places? 1, 2, 3. Remember, like we said earlier, if it moves over to the right, f of x, let's put a negative number there, right? So now this is what this function would look like if we just stopped moving it. But since we move it down 2, we're going to take away a number. We're going to go minus 2. So you're going to go, you move this down here and you'll get this. So your two numbers are -3 and -2. So -3 minus 2, -5, or A. So 29 I actually solved on the video when I first released it, so check the video for solutions. Let's look at 30. 30, we're given a function here. This is 2, this is 1. Right, so we have this line here, and this is just calling this f of x. And they're saying g of x is going to be defined by whatever value f of x takes plus 4 to it. Find the x-intercept. What is the x-intercept, right? Well, that's whenever x crosses this line, or when y is 0. When y equals 0. So let's look at this. So first let's get some characteristics of f. What do we know about f? Well, we know f has a negative slope, so m must be negative. What else do we know about f? Well, we know we have its rise or run here, right? So you could go this way, left and up, which is consistent with it being a negative slope, but it runs, or it rises 2 for every 1 unit it goes over. So the slope is -2 over 1, right? Or just -2 equals m. So we have y equals -2x plus b. What's our b? Our b is just our y-intercept. Well, we know what that is, right? Because when x is 0, we get 2. So in fact, we have the entire function here. So the entire function, this is f of x, right? So you're saying now what it's saying is g of x equals f of x plus 4. So I can just add 4 to this, right? And I'll get g of x. So I'm going to get g of x to be g of x equals -2x plus 6, right? So it's actually a parallel line. And from here, so what it would look like, it would be up here somewhere, right? Let's say this is 6, and you would get a line that goes somewhere here. Something like that. And we're looking for where the x-intercept, or this part. So you could just set it for 0, do -2x plus 6 equals 0. You can solve for this, -2x equals -6, -2, -2, right? X equals +3, right? And that makes sense. That's consistent with this, right? It's bigger than 1. It's on the right side of the x-axis. So x equals 3, right, is a consistent value for the x-intercept. Yeah, so that's just an easy way to do it, is that we use what they're giving you, right? So they gave us a good image here, and let's use it to